Let's look at dimensional analysis. It's also called factor label, and it's also called unit conversion, and you may have heard it have a different name from your chemistry teacher if you ever had chemistry before. Dimensional analysis has kind of this look to it that makes it kind of a unique chemistry thing. It'll be multiplying multiple things, and they always look like you're multiplying fractions. Well, the point of dimensional analysis is to make it so that when you're reading a word problem, or even just doing some simple conversions, instead of thinking through, oh, does the word of mean I need to multiply? Or does the word equals, does that mean equal sign? Or does that mean something else? Instead of having to ask yourself about those Q questions about, those special little words in word problems, you let the units tell you what to do. And what I mean by that is you intentionally set this up so that the units are at diagonals. So maybe you can see that those are diagonals. So that's what we're going to be teaching. We're going to be starting with 1 steps, which is just this portion of it. And then we'll move on to practicing 2 steps and then 3 steps. And just wanted to let you know where you're headed is going to be something more like this most of the time. But of course, you'll have some 1 and 2 steps. It's no big deal to have some of the faster problems as well as some of the harder problems. And hopefully what you'll find once you get comfortable with this method is that it makes it so that the math is less thinking and more about playing a little matching game. Another way this also might look, and I use this method quite a bit because for me it helps me keep my numbers neat, is you might see something with a long line, and then instead of multiplying signs, there's these like vertical lines. And it would be filled in the same kind of way. So I'm filling this in. And all you need to know is that, of course, when you go across the top, it's multiplying. And then everything on the bottom is dividing. Let me show you. So right here, these numbers are all multiplied. So it's kind of like this line right here means multiply, multiply, multiply. And then these are each divided by numbers. So it's kind of like the lower section is kind of like divided by, divided by, divided by. So I don't know if that helps or not, so that you can kind of see what that means. But I think it helps keeps the numbers really neat. So if you struggle with, your page being neat, you might like this method. But if you like seeing multiplying and dividing, you're totally welcome to use the top method. All right, so I've pulled in these metric units, and these are the exact same ones. If you go back to the metrics video, these are the ones we already figured out. And I've got some problems, and they're simple ones, they're just 1 steps that we're going to work. So when you do the first one, a lot of people like to do this. If you're short on time, you don't have to, but they like to make a little note like, this is what I'm looking for. That's where I'm going, is trying to figure out this one. This is the one without a number, so that's kind of your help too. And then we're going to take 3.0 grams. And what I'm going to do first is I'm just going to put the units in place, since this is the first few times you'll be looking at this method. So I'm going to put a gram here, and I'm going to put a gigagram here. And the reason we do that is because I'm trying to get this unit that's down here, this gram unit, I need it to be a diagonal. And the reason is because when I get to the end, remember you multiply across the top? So it's like saying grams times a gigagram. Those are my units across the top. And then my only unit on the bottom is a gram. And the reason this is helpful is now I have a gram over a gram. And I've basically converted from a unit to another unit. And I'm going to show you on this one, 5.0 milliliters. And I need to get rid of milliliters, and it wants me, and I didn't put this over here, it wants me to go from a milliliter to a liter. And again, like I said, over here, units-wise, this is a milliliter times a liter over a milliliter. And again, those guys are going to cancel, so you're left with a liter. And then right here, 1.0 liters, and I'm looking for a picoliter. 1.0 liters. And then I'm going to go from liters to picoliters. And again, on my units, it's liters times picoliters over a liter. And my liters will cancel, so I'm left with a picoliter. So it's kind of showing you what's going on with the units. And right here you can see, again, that's a diagonal. and that's a diagonal. And that's what you want to have happen. You want to match up the diagonals. Now you just have to put the numbers in the right places. Now a quick note, notice this problem didn't state, hey, this is the conversion you need to use. It needed you to recognize that you were going from something in the metrics unit to something else in the metrics unit, and assume that you have a copy of a metrics chart, which you do, and there are plenty of them in the lesson. So that's one piece of information with chemistry. You may need a metrics chart. You're also going to see coming up that there might be an English to metrics conversion chart that you might need. And ultimately, moving forward in chapters 2 and on, you're going to be using numbers on the periodic chart to get between different units. So let's just fill them in and finish it up. So right here, it's right up here. Here's my conversion I'm going to use for that one. Notice the 1 is with the prefix, and this is 1 times 10 to the 9th. I'm going to fill in the next one down, so it's over here, milliliter, liter. And again, the 1 goes with the milliliter because that has a prefix. And then this one is the one I want. Oops, there. And then again, the 1 goes with the prefix, and 1 times 10 to the, it says negative 12th. And if you want to watch me put it in a calculator, this one has, I have to use the second key right there, and then I have to use the key that's with the comma. There's a little EE in the corner. That's how this calculator does it. A lot of TIs are like that. So 3.0. And I can put times 1. You do not have to if you remember that anything times 1 is itself. Divided by, now this is where I've got to use that scientific notation, or I'm going to be pushing a lot of keys and I've got to remember a parentheses. So 1, that's the exponent. It's represented, like, it's weird because on the keyboard it's EE, but then in the formula it just looks like an E to the 9th. So this answer is... And I'm keeping my 2 sig figs. We'll talk a little bit more about sig figs coming up on these, but that's 2 sig figs, so 3.0 times 10 to the 9th. I'm going to do the next one, 5.0, and if you want to put the 1 in, you can. Oh, it's actually not a 1, it's 1 E to the, now I'm using my negative in parentheses key down at the bottom, 3. I'm not using the negative sign that's on the far right. And so this one gives me 5.0 times 10 to the minus 3rd. And then the bottom is 1.0. And again, times 1 divided by 1, the exponent key, the negative key, and 12. So that gives me 1.0 times 10 to the 12. Now you may be thinking, well, what's going on with the sig figs here? All right, so when you're within the metric system, like anything that came off that metrics chart, we call all those numbers exact. And what that means is that you can ignore this whole thing, not for the math, but for the sig fig counting. So the only numbers that will have any application for sig fig in this one are those 2. So that's 2 sig figs. That's why this has 2 sig figs. And again, this is all in the metric system. It's called exact. And so you don't have to worry about those for sig figs. And so this has 1, 2, which is why I put 1, 2. And then lastly, again, this is all in the metric system. It's exact, so you can ignore the top and the bottom part, that conversion. And then I have 1, 2, and 1, 2 sig figs.